Okay, so we are going to look at the intermediate value theorem. I was a little concerned about putting it through video, but I think we should be okay. Just kind of make sure if you need to, watch this introduction part of the video a couple times if you're not quite confused. It's not terrible, okay? So first off, this is your first existence theorem. In an existence theorem, two things. One, note, you got to memorize this. Okay, it's a flashcard. You have to turn this into a flashcard. An existence theorem is where we say, hey, I know this is true. I know that this exists because blank. Okay, this is an existence theorem. So in this case, what we're going to do is we're going to say, hey, I know some y value exists. Okay, and here's why we do that. So if you would, please, watch it, pause the video, get down the theorem itself. Okay? Hopefully you have paused the video and you're good to go. Let's talk about the existence theorem. So I'm going to ignore example 8 for right now, and I just want to kind of explain the intermediate value theorem. So here's the way the intermediate value theorem works. It says, hey, if you have a continuous function on the closed interval from a to b. So let's call this, this will be the point a f of a. And I'll put this b, this will be the point b f of b. Let's put it here. And the function that we're looking at is continuous on that interval. Okay, so on this interval, we have a continuous function, whatever it looks like. What the intermediate value theorem says is if there is some k value, right? Some k value. So there is a height value. So basically some y value on that interval that is between f of a and f of b. So if the y value, this is important, if there is a k value that whose value is between f of a and f of b, then there must exist a c. So there must exist some c on the interval from a to b such that f of c equals k. Okay? So let me give you let's just look at this value, for example. Let's do that. Let's kind of look at this one. Let's put in some real numbers here. Let's pretend, for example, I'm going to get rid of some of this here. Let's say we knew some of these values. We don't, but we're pretending. Let's say the first point is the point 1, 1, and then the next point we'll say is the point 5, 6. Okay? Then what we're going to do is k is going to be some number between the outputs, right? The y values between 1 and 6. So let's say in this case that k equals 3. So what this says is because this function is continuous, there must be some points. And I think you'd agree there's probably a point here and probably a point here and probably a point here, such that f of c, so the c is, I'll call this c1. There's some c value such that f of c equals k. Now, the key here is the intermediate value theorem only says there must be at least one. Because I think you'd agree, if we didn't know what this graph looked like, let's kind of get rid of this. Why is that erasing well? Let's just say I told you, hey, look, we have some graph, right, that's continuous from A to B. You just have no idea what it looks like. But again, we know that this 3, this k output value is between f of a and f of b. Let's keep those numbers again. So in other words, we know that 3 is between 1 and 6. all we know from this function is that there must be at least some c value on the interval from a to b such that f of c equals 3, right? And that kind of makes sense if you think about it. It could be, I'll do this in a couple ways, maybe the graph is just a line, so there's only one point, right? On the other hand, so maybe there's some c value right here where f of c equals 3, and there's only one value. On the other hand, like we saw before, there could be multiple values. So I could have a graph that looks like this. Let's do it in orange, right? And we could say it looks like this, right? And now there's multiple c values. I'm going to just highlight them. There's a value here, 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 such that f of c equals 3. So again, the intermediate value theorem doesn't tell you the number of places that f of c has to equal that k value. It just says there has to be at least one. But, and this is important, in order to use the intermediate value theorem, you have to establish that it's continuous on the closed interval from a to b, and that f of a does not equal f of b. Okay, those two things have to be established. So let's see how this works. Let's go and play with this in a real example, and hopefully this will clear things up. So the first thing we're going to do is we're going to look at example 8. Let's get rid of that. I kind of want that. I hope you guys can read that okay. I know the lines make it a little weird. So the first thing I want to do is I'm going to look at example 8. Let's see what it's saying. It's saying here you have this polynomial function, and we want to show that there has to be a 0, right? So there has to be a 0 on the interval from 0 to 1. So I think you guys would agree if there's a 0, what we're really saying is f of c has to equal 0. So our k in this case, right, this k value that we're looking for is 0. Okay, so we've identified what we're looking for. We're looking for some c on the interval from, 0 to 1 such that f of c equals 0. So let's go through what we have to do. The first thing we have to do is we have to establish, is the function continuous? Well, yes, it is. Last week or the week, I guess the week before at this point, you got a list of all the functions that are continuous on their domains, right? So polynomial functions are continuous on their domains. If you didn't, let me just scroll back here really quickly. Maybe get these down. Again, these are the types of functions that are continuous on their domain. Okay, let's go back. So we know that this function is continuous. I'm just going to put a check here. The next thing I want to do is I want to establish, basically, it's more than just establishing that f of a does not equal f of b. What I really want to establish is that f of c is between f of a and f of b. So let's see. F of a is going to be 0, right? And f of b, in this case, is going to be 1. I'm grabbing these from the endpoints. So I'm plugging the endpoints in, and what I'm hoping to see is that f of c is in between those values. So let's see, what is f of 0? Well, f of 0 is 0 plus 0 minus 1 is negative 1. And then what is f of 1? That's 1 plus 2, which is 3, minus 1, which is 2. So I think you guys would agree with me that f of c in this case is between negative 1 and 2, right? 0 is between negative 1 and 2. Okay, so what does this mean? This means the intermediate value theorem applies, right? Because the only requirements for the intermediate value theorem is that we show that the function is continuous, which it is, and that really, I'd like to let's kind of say this a little bit. We'll kind of do this as a side note. Okay, really what we're establishing is that this is in between these two. By the way, obviously, f of b and f of a could be switched. So let's go and say that. Let's go and say it. So, let's say. So I'm just gonna start. I'm just gonna kind of recap. I'm gonna say the function. Oh, I'll write it. I was going to type it, but I'll just type it. So I'll just write it. So the function f of x is continuous. How do I know it's continuous? Because it's a polynomial. Okay, so the function f of x is continuous because it's a polynomial. And maybe I might say, if, especially if, let's say the function wasn't always continuous, but it was continuous specifically where I wanted. Maybe, maybe we had a rational function, it wasn't continuous everywhere. But the only thing I really care about in this case, is it continuous on 0 to 1? So polynomial functions are continuous everywhere, so that's fine. But what I might say, if I need to, is I might say, okay, the function is continuous, the function f of x is continuous because it is a polynomial, specifically, however you spell this word, specifically, it's continuous on 0 to 1. This is the big thing. Really, the only thing I care about is that it's continuous on 0 to 1. In terms of the continuity discussion, that's all I care about. Next, let's go through. The next thing we have to do is establish that f of c is between f of a and f of b. So then I'm going to say f of 0 is less than or equal to f of c. Whoops. Let me rewrite that. That's a little confusing. One more time. So I'm going to say f of 0, which we already know is equal to -1, is less than or equal to 0. If you want to, you might put f of c. I don't care. This is fine for me because they're equal. So that's really up to you. I won't even include it. Because I figure most of you won't like to do that either. And then I will say f of 1. So all I've done here is I've established this value right here is in between these two. Okay? So I have established that I can use the intermediate value theorem. I have, 1, shown that the function's continuous on the interval specified. Oops, I didn't mean to cross that out. Right? I've established that it's continuous on the interval specified, and I've shown that the k value, right? That f of c value, that k value that I'm looking for is between the two endpoints. So then I'm going to say, by the intermediate value theorem, this is a fine abbreviation. You can use it even on the AP. So by the intermediate value theorem, there must exist a c on, I'm going to be specific. Where is this c? Remember, that c is an x value, and it's on the interval from 0 to 1 because these are the domain values that we're looking for. So there's a c value on that domain from 0 to 1 such that f of c equals 0, right? What we were specifically looking for. That's all there really is to it. I know this is going to feel a little uncomfortable, and really it comes down to practice. That being said, I think we should practice. So let's do this one. So here's what I want you to do right now. Let's determine if the intermediate value theorem applies. So remember, in order to determine if the intermediate value theorem applies, we need to know, is the function continuous on the interval that we're looking for? So figure that out right now. Then I need to figure out if this is true. Is this true? Yes or no? Okay, so I'm checking, is that k value between the f of 0 and f of 3? Go figure that out. Okay, let's go and check. I actually haven't done this one. By the way, let's just really quickly, since we're on this conversation, let's say one of these things fails. Let's say the function's not continuous here, or f of c is not between these two values. Then we can't use intermediate value theorem. If one of those two things fails, then you can't use it, and all you would say is intermediate value theorem does not apply because blank. It's not continuous here, or f of c is not in between these two. So let's see what we got. I do know this is a polynomial function. Polynomial functions are continuous everywhere, so it's going to be continuous on 0 to 3. That is going to be taken care of. So the only thing I'm really concerned about here is this is true. So let's see. So f of 0, what is f of 0? F of 0 is -2. And then what's the other one? F of 3. What is f of 3? 27 minus 9 is 18. Plus 3, 21. So 19. Hopefully I did that right. Whatever it is, it's way bigger than this. So this is going to be true. I'm assuming I did that. If I messed up and it's not 19, I should still be okay. Get the right number, but I'm doing it in my head and I'm being lazy and not double checking it. So what I want you to do now, we have satisfied, orally we satisfied this. You're going to have to kind of be specific. And we've established, that the C, we've established this. Go and put that down. Okay. Let's start. Justify that we can use the intermediate value theorem first, then write the conclusion. Okay. So I'm going to say, and the order doesn't matter here. So maybe this time what I'll say is hey, look. F of 0 is less than or equal to 4, which is less than or equal to f of 3. Okay? I've established that the k value that I'm looking for is in between f of a and f of b. Next, I'm going to say the function f of x is continuous. I'm just going to say on 0 to 3 because it's a polynomial. Is a polynomial. Okay? So I've done all I need to do in order to use the intermediate value theorem. I've shown that 4 is between f of a and f of b. I've established that the function is continuous. So conclusion. Now remember, this is important, okay? So pay close attention. The intermediate value theorem is guaranteeing a domain value. It's guaranteeing an x value such that, that x value is c, such that f of c equals the output, equals the y value of 4, okay? That's important. It's not guaranteeing this, right? That's given. It's not guaranteeing that f of c equals 4. It's guaranteeing the c value, okay? So all I'm going to say is you have to name the theorem. So by the intermediate value theorem, don't forget, name your theorem. So by the intermediate value theorem, there must exist a c. Where is this c? Oh, on the interval from 0 to 3. And what is special about that 3? Such that f of c equals, in this case, right, 4. That's it. That's the intermediate value theorem, okay? Practice these. Practice. Ask questions when I come back on Tuesday.